I don't know where to look. All right, guys. So Aaron just put up the knife maintenance video, and a couple of you guys had questions about the dual stop pin system. This is something I haven't really talked about like ever. So real quick, I'm just gonna go through it, explain the hows and the whys. So, you know, this is like 2014. I'm thinking to myself, okay, one pin is controlling two different things, the open position and the closed position. And if I make an adjustable pin, it changes both. So if I need more lockup, it also changes the detent. And if I need less detent, it changes. So it's like, it's related. So I'm like, okay, it's related. How do I separate them into two different things? And then I'm like, what if I had two stop pins? Okay, would that work? I don't know. So I drew it up and I'm like, I think it would work, but I didn't have time to test it out. And then eventually I tested it out. Eventually, like probably late 2014, maybe early 2015. I'm like, wow, this kind of works. But then you need this whole range of pins. And I had the Tormac lathe at the time, so I was making the pins, and it was, you know, tough to chase tolerances. It's still tough on the Nakamura to chase those tolerances. But eventually, one day, you're just like, lying in the sand, I gotta start doing it this way. It is better, I gotta commit. Let's make up an inventory, and let's just do it. And we did, and no looking back. Like now thinking of the old way to do it is like ridiculous. Like I wouldn't go back to the other way where you're like filing the end of the lock bar and like hand tuning it. No, it's just put another pin in, and it's like you get so used to the new method. And there might even be a better way in the future that we'll find out eventually. So always looking for new things, always improving. I mean, this knife evolves almost every time we make it. So it's really fun, it's really cool to see. I'm sure there's changes coming in the future too that I haven't even come up with yet. So I got two knives here, an old one with a single stop pin and a new one. Eric is finishing this up right away. It's not fully assembled, but brand new knife, sharp, ready to go. So I can explain using these two as examples. So Eric's got this thing assembled with kind of crappy screws. Ta-da! So this is our assortment of various size stop pins. We make them in-house from 17.4 pH stainless steel at H900 heat treat, which is 45 Rockwell. Nice. And thank you, Eric.
You're welcome.
You may go now. If you notice the labels right here, you can see, you know, so we want the nominal size to be 125, but this gives us a range low and a range high. And then we have small ones back here and big ones back here. I'll show you in a second on the knife what that means. But if you look super closely at this one, notice how there's a middle section that is smaller. That's where the knife contacts. The two outer shoulders go into the handles. So where did I get it from? I think I got it from here. By varying the stop pin that we use, it varies how the knife is fit together. All right, so I've got this one pulled apart. So in here, notice how there are two stop pins. The fact that one's in one handle and the other handle, it doesn't really matter, just how they happen to come out. So that's two. Let's pull apart the single knife. Boom, comes right apart. So this one has a single stop pin. So the first difference, so I'll show you how a single stop pin works. So when the knife is fully open, the stop pin touches there. And when the knife goes fully closed, the stop pin touches there. Kind of simple, makes sense, right? Now with the lock side, how it goes together. So in the open position, that lock bar is spring-loaded. It moves over and it stops the blade. It gets in the way of the blade from closing down. Now, tuning the open position. Imagine if it opens more, this lock bar is going to go over more. If it opens less, this lock bar is going to go over less. So this is your lockup. This knife happens to be, I don't know, 10 or 20%, which is kind of early, but it works fine for me. By changing the stop pin size, we can change how much lockup, basically as much as we want. So it really helps dial in the tolerances between all the different knives. Even though we manufacture these on like awesome CNC machines, there's always tolerance, there's always end mill wear, there's always something. So having a range of adjustable stop pins really, really helps us dial this in to make setup a lot easier, because what most guys are doing to mess with the lockup, they're grinding this lock face a little bit, assemble, put it back together, grind it a little bit more, assemble, put it back together, test. Or like we used to do, they're shaving down the face of the lock bar, the end of the lock bar. And we used to do that for years. And it's just like, cut a little bit more, put it back on, cut a little, assemble, take it apart, cut a little bit more, put it back on, assemble. You know, we'd spend like 30 minutes dialing in every knife, and that's what you have to do until you figure out better ways, which we've done here. So I told you how to mess with the lockup. The other aspect is the closed position, what I like to call the detent position, because that's where your detent ball falls into the hole on the blade, and that's got to be dialed in perfect as well. So the closed position is super important for how the detent ball falls in there, how the knife feels when it's closed, if there's play, if there's springiness, how it pops out, like super critical, especially with our knives. We're like crazy picky with how this all works. And you can see the difference here in the blade. If I gently stack these two blades on top of each other so Eric doesn't yell at me. So if you look right here, Aaron, like straight on, you can see on the second blade below, the stop pin stops. The top blade, the newer blade, has a much wider arc, let's call it 180 degrees, whereas the lower blade has a, I don't know, 140 degrees, whatever it is. It doesn't go as far, because this basically leaves room for a second stop pin, right? So there's that much more room in arc travel. So if I assemble this new knife, and it is sharp, so I have to be super careful. So you can see how it works right now. The small pin controls your detent, and the large pin controls your lockup, and now they're completely separate. So if I just need to change lockup, or Eric now, because he's the one that does all the assembly, he can just choose a different size pin. He can put it together once, be like, oh, it needs a little bit more lockup, and then choose a different size pin, and same for the detent. So they're separated. This is, you know, I say this with air quotes, but this is patented Grimsmo technology. It's just something we started to do, and I'm really, really happy with how it's working. Eric likes it. The tricky part is making these pins to basically a 2/10 tolerance, a 2/10,000th tolerance is a pain in the butt. So that's fun, and you need a big range, and et cetera, et cetera. And Eric says even as we're making more and more knives, like throughout a week, he can tell that the end mills are wearing down, because his stop pins, he's like, okay, I'm going a little bit higher. A couple days later, a little bit higher, and then I change some tools, and it goes back down to 0. And it's like, whoa. So it does fluctuate a little bit, but this gives us the range and the wiggle room to like do it pretty consistently. So having the range of pins is a pain in the butt. We make them ourselves. It's not easy to chase that tolerance. There's, you know, shoulder, center, shoulder, and each one's different. They should be the same, but on the machine, because of deflection and everything, like, it's just different. But it's worth it. This is how we do it. This makes Eric's life easier, and I love it. So hopefully that makes sense. I think it should. Yeah, I'm really happy. We do the same thing on the Rask, but I like it. Hopefully that is clear. So this knife right here, number 906, at number 900, I got to try something that I've always wanted to try. I actually tried it on knife number friggin' 0. It doesn't even have a number. So I called it the Easy Groove back in the day. You can kind of see it in there. But anyway, it's this little slash right there. And what that is, it's a detent ramp. Now, other knife makers have done this too. It's no big deal. It's nothing new. What it does is this little ceramic detent ball now has this like gentle slope up the blade. So when you unlock it, you get off the lock face, you move it down, and you don't feel that detent ball anymore. It used to catch really hard at the edge of the blade, so you'd unlock and then you'd have another catch right there. And it was fine. It's what we were used to. It's what everybody likes. It's what the Norseman is, but I really wanted to try this. So starting at number 900, we tried that, and I'm really liking it. The only thing is, the knife sounds, it actually sounds different. Let's see if I can do this with a non-properly assembled knife. Maybe I should put the other bearing in. So try to get that sound. It just has this kind of thunk at the end, whereas the other ones had this click click, because you could hear the detent fall off and then the lock bar engage. It's weird to like change the sound of the Norseman, something we've made 900 of, that used to have this click click, and now it's just thunk. I think it's cool. I think it's awesome. I think the benefits far outweigh the weird sound difference. And I think it's an improvement. So it's something I've always wanted to try. So I'm glad we're doing it. So that's what that is. And there you go. Further insight into what a Norseman is all about. And we're having a blast. Yeah. All right. Thanks for watching. Bye.